Guys, today we'll be starting from the portion from where we left off the last video. Right, remember we first learned about our resistor, right? When it is in an AC supply, what will be the nature of the induced EMF or alternate voltage and the current, and what was the equation? E naught sine omega t, and current was I naught sine omega t. And we learned about phasor diagram, then we learned about power. Right, now this and all were the common things which we learned regarding the resistor, and we start with with the inductor circuit. Right, that is what happens if I replace the resistance with an inductor and the same AC supply, so that the EMF which we have provided as an input is E naught sine omega t itself. But we found that the current I is equal to I naught sine omega t minus pi by 2, right? Because it was minus cos omega t, that means we can also write it as what? Sine omega t minus pi by 2y. Sine theta minus 90 is minus cos theta, something which you have learned in your lower trigonometric classes, right? Now what we are going to do is, what do you infer from this equation? That means there is a phase difference of 90-degree between EMF and current, right? I can easily say that the current is lagging behind, or it lags behind what? Voltage or EMF, right? Because the current is lagging by how much? It is lagging behind voltage and EMF or EMF by an angle of 90-degree, minus pi by 2, right? That means once the EMF has covered a cycle, right, then the, right, that is if it is reached here, right, one cycle has been started by the EMF and it reached the point here, means at that time interval when the EMF has completed half cycle, then the current wouldn't have completed the same cycle. It would have reached by only 90-degree. How much? That means it would have reached here only, right? That is, the current would have reached this much point only. Clear? By the same time interval. That is, if I draw the diagram, right, you can draw the diagram for it. See if you guys are able to draw it by yourself, or if not, I will draw it. Okay, pause this video and try to draw it by yourself. Now let's see. Right, you know the voltage, no, the amplitude will be how much? Voltage amplitude will be larger than current, that we have discussed earlier, because what? Voltage is, if it is divided by resistance, I get current, right? Or if we write in place of V, I can write E naught, right? E naught by R is I naught, right? So current is ratio of what? Voltage and resistance. So current is always less than EMF. That's why the amplitude will be less of that current. Clear? When compared to the what? EMF. Right, now I'm going to draw the what? Sinusoidal waveform, graphical representation, how would be. Right, now some of you guys would have drawn by yourself. Let's first draw the voltage or the EMF. Right, one cycle like this. Right, now peak voltage will be epsilon naught. Right, then this is pi, right, that much you know. This is 2 pi, right, this is omega t, right, this axis, right. The current will be, let's say, the maximum amplitude, let's say this is I naught, right, that is the maximum current that is possible. Now I'm telling you what is pi by 2. This is pi, means the pi by 2 will be here, right. So the current is lagging behind what you say as voltage, right. That means the current, I'm going to just listen. So once the current will be reaching its, see, let's say the peak point, I can say about the peak point. So here the voltage has reached its zero, right, whereas the current at that time would have reached its peak like this, right. This is the diagram. That is, see, voltage has already started, right? voltage or EMF, but the current will start only after 90 degree, like that. I hope this much is clear. If you want, you can extend it like this also. Clear? Not that much of tough, right? This is how it is graphically represented. The voltage, I can say, or current is either, let's say current is lagging behind voltage by 90 degree, or voltage is leading current by 90 degree. Both are correct. Clear? Easy, right? Now let's move on with the next section. If it is not clear, you guys can pause the video and try to understand it. Right, now let's move on. After graphical representation, there is something which you have to know. I think I have taught you about what impedance, right? I told you I0, right, is what was epsilon naught divided by L omega, right? And told you L omega can be written as what is the resistance which is offered by the inductor, hence it is known as inductive reactance, right? So it is represented by XL, right? And what is the resistance unit? It is ohm, L. Similarly, the inductance reactance or inductive reactance unit is also omega. Keep that in mind. Clear? Now let's move on with the what is the average current over a complete cycle? It is 0, right? Just like the previous case. Similarly, what is the average voltage for a complete cycle? It will be 0. Right, then we guys can, if current and voltage, if it is there, the next topic which we have to deal with is what? Power. Right, just like in the case of resistance, power associated with an inductor. So how would you move? Just like the previous case, if you want to find the power, we require both equations of voltage and current, which is E is equal to epsilon naught sine omega t, right? And what is current? I is equal to I naught sine omega t minus pi by 2, right? Yeah. Now what is the instantaneous power? P is equal to VI. So I can write Vm, or I can say here it is epsilon, right? So I will write it as, in place of V, or I can write it as epsilon I. So I can write it as epsilon naught sine I omega t into I naught sine omega t minus pi by 2, right? Just substituting. Or I can write it as E naught I naught sine omega t, and this sine omega t minus pi by 2 I can write it as what? Minus cos omega t, right? Just like the previous cases. So I can write it as what? Minus E naught I naught sine omega t cos omega t. This is the expression for instantaneous power, right? That is very small power. But what is our main section? I want to find its what? Average power, right? Average power, if it is found or supposed to be found by which expression? Remember, integral 0 to t p dt, right, divided by integral 0 to t dt, right? Or I can write it as, the denominator will become what? T. So I can write it as 1 by t integral 0 to t p dt, right? Clear? Now this p is from this expression, right? Can I change this expression in any other way? Listen guys, something which you have learned in trigonometry. What is sine 2 omega t? Sine, or I can write it as, let's say, as 2x. That might be the way you have learned, or 2a is equal to 2 sine a cos a. Something you have to learn in trigonometry. Now I can write sine 2a by 2 is equal to sine a cos a, right? Keep this equation in mind guys, right? Now we have an equation for power here, right? And here there is an sine omega t cos omega t, that is in place of a I am having omega t. So I am going to substitute this sine omega t cos omega t just like this, so that it becomes sine 2 omega t whole divided by 2, right? See the equation again guys. What I am going to write? What was the power's equation? Was what? Epsilon naught minus, right? There is also minus, right? Sorry, minus epsilon naught I naught sine omega t cos omega t, right? Now what I am going to write is minus epsilon naught I naught 2 sine omega t whole divided by 2, right? Clear? Now I am going to find for average power from this, that is average power, right, is equal to 1 by t, right? Integral 0 to t, right? Epsilon naught I naught. I am going to bring the minus outside here, right? Clear? Divided by 2 sine 2 omega t dt, right? This expression. Now this epsilon naught I naught by 2 is a constant term. I can bring it outside, right? So it becomes minus 1 by t, or epsilon naught I naught by 2 integral 0 to t sine 2 omega t dt, right? Clear? Simple. Now in the earlier case itself, in the earlier class itself, I told you for a single time period, for an entire time period, sine function or cos functions are all equal to 0, right? So this entire term goes to 0 means I can say the average power, right? This is average power. This entire term goes to 0. So the average power supplied to an inductor over one complete cycle is 0. It has instantaneous power, but since this term is equal to 0, this entire term goes off, right? So the average power of an inductor circuit is 0. But in the case of resistor, it is not 0. Remember. Clear? Right? Now, we dealt with almost all the topics. Now what is the pending one? Phasor diagram, right? I hope you understood how to draw a phasor diagram in the case of resistor. Now similarly we are going to draw for what? Inductor also, right? So I'm going to draw phasor for here. Yeah, either you can compare it with the graph. This is our graph for remember we drew the graph. So this was pi, this was 2 pi, remember this was 3 pi, this is omega t, and this is pi by 2, right? Pi by 2. So from pi by 2 only our what starts? Our current starts like this. Yeah, this was the current circuit, right? This is voltage, this is current, or you can write it as EMF like this. And the peak is epsilon naught, current is I naught. Something we have been taught, this will be negative when this will be what? I naught minus I naught, this will be minus epsilon naught. Yeah, this was the graphical representation, right? Now, so how would I draw for what? Phasor diagram for let's say for inductor. So we will take any angle, let's say this point, this is omega t1, say, right? I will draw a line like this. This is omega t1, okay? This point is with what? EMF, right? So with respect to omega t1, I'm going to draw a line like this straight away, right? Now with the same angle omega t1, I'm drawing so that this angle is omega t1, right? So I drew an arc like this, or drew a line like this, right? Now this vector is for what? Our EMF. Clear? And this magnitude is here, this one. Clear? Simple. Now see this omega t1 itself, I am going to extend downwards so that, let's say this was our current, right? So this is the point where the current meets omega t1. Alright, let's move on here. I am going to extend the line here, right? So that means, but I have to take what? By 90 degree backwards like this, so that this angle which I am having is pi by 2. See, this is 90 degree behind, right? So this is my current, right? Clear? Right, so this is my phasor diagram. You need not compare it with the graphical representation. See, I will tell you a simpler way how to deal with it. Right, I'm going to rub it this one off. Okay, let's make a larger section. Right, I'm rubbing it off. Without this graphical representation itself, how can I draw the phasor diagram? Oh, sorry, let's remove it totally. Right, so this is my axis, right, for what? Our phasor diagram. Okay, now I took an angle. Let's say this one is for EMF. Right, in your textbook it is V, it's okay, E, and it is at an angle omega T1. And I told you by theoretical method itself, I told you the current will be behind, right, it is behind EMF by an angle 90 degree. So this is how you are supposed to draw, and you know that the amplitude of current is less than V. So this is how the graph should be, or phasor diagram should be. Very easy, right? So I told you by comparing, because it is very important to understand how it is actually drawn. Okay, I hope this much is clear. Right, let's move on with the what. Now after inductor, which circuit has to be learned? The capacitor. That is, if the circuit is having only capacitor. Right, now capacitor AC circuit has AC voltage and only circuit element present is capacitor. Right, so suppose I am sorry, I didn't take. I am going to take the diagram like this. The capacitor, this one is a capacitor, and there's an AC supply. Right, and the source voltage of the applied voltage is epsilon is equal to epsilon naught sine omega t. Right, now in this circuit, the capacitor is continuously getting charged and discharged in it in each half cycle. Right, so therefore the applied voltage will be across the plates of the capacitor. Right, so what is the voltage applied in the place of the capacitor? V is equal to Q by C. You have learned in the first chapter, where Q is the charge on the capacitor. Right, and what is V? Here it is epsilon. Right, so I can write epsilon is equal to Q by C, and in place of epsilon I am going to write it as epsilon naught sine omega t. That is applied voltage. Right, so epsilon naught sine omega t is equal to Q by C. Right, clear? Now I'm going to bring, or I'm going to differentiate, because we want, what is the end result for all the cases? First we apply EMF and I want to find what is the current, right? But here from this equation I can never find current, right? But I have a term called charge. So can I reduce or produce what? Current from this quantity? Yes. How? Sorry guys. First I am going to extract Q only from this equation, so that this C goes here. So it will be C epsilon naught sine omega t is equal to Q. Now what is dQ by dt? It is current, right? So I can generate current from here. So what should I do? I have to differentiate this entire equation, right? So that when I differentiate, it will be dQ, okay, dQ by dt dQ by dt is equal to C epsilon naught. This is a constant term, d by dt of sine omega t. Right, simple, because both other terms are constant. Now what is d by dt of sine omega t? What happens when I differentiate sine? I get cos. So it will be dQ by dt is current, right? C epsilon naught sine omega t is cos omega t, and there is a term omega t also. So it is omega cos omega t. Right? Now, moving on, in terms of sine function, right? So that means I have to write simply in terms of sine function. I have to write, why? You have epsilon is equal to epsilon naught what? Sine omega t. So I want to write current also in the terms of sine itself. So how can I write current? I will write I is equal to C epsilon naught omega. Keep it as a constant term. And in place of cos, I am going to write sine omega t plus pi by 2. Why? Sine x plus 90 or sine theta plus 90 is cos theta, right? So now I have written both EMF as well as current in the terms of sine. Just there is a small difference, that is here in EMF it is omega t, in place of current it is omega t plus pi by 2, right? That means I have a constant term also, right? That is, there is a C omega or C epsilon naught omega, right? Now this term can be put into a value, that is I naught, right? So that this entire constant term is replaced with I naught, means it is I is equal to I naught sine omega t plus pi by 2, right? Now these two equations are comparable, right? So this constant term is replaced by I naught. Clear? Just like in the previous case, right? This is the current amplitude. Clear? Right? So this equation which you have got is the expression for the current through the capacitive circuit. Clear? Keep it as it is. So this is EMF, this is current. Clear? Now what is capacitive reactance? Just like the case of inductor, there is a capacitive reactance also, right? We just wrote I naught, right? We replaced constant term I naught as C omega naught, sorry, C epsilon naught omega, right? So actually what is current? It is supposed to be written as epsilon naught by any resistance value, right? So can I write this value like this, epsilon naught divided by 1 by C omega, right? I can write it because C omega goes up, so this term itself is generated. So this is R. So in place of resistance I am having a term called 1 by C omega. So this 1 by C omega is the resistance which is offered by a capacitor, hence it is known as capacitive reactance, right? And it is represented by XC, and the SI unit is same as the before, it is ohm. Clear? Clear? Right, I hope this much is clear. So this capacitance XC depends upon the capacitor's value of C and as well as omega, that is angular velocity. Clear? Now similarly in the previous case of that of the capacitor, sorry, inductor, here also I have to draw what? Graphical representation. Right, now that is where we are going to, right? So all the topics are having the same format, guys. First you will deal with the current voltage equation, then you have to deal with the resistance values or reactance values, then you have to deal with the graphical representation, then you will go for the power, then you will have what? Impedance, sorry, the, you know, the graphical representation. Similarly you have the phasor diagram, right? I'm sorry. Okay, so let's move on with the graphical representation. By now you might be knowing how to draw it, right? So how do I draw? So this is your axis, right? So first you will draw voltage, or I can say EMF, right? So this is our epsilon naught. This is the graphical representation of epsilon, right? Now the current is such that it has leading, right? What was the equation? Remember, E was E naught sine omega t, whereas current was I naught sine omega t plus 90. That is, before the EMF comes, the current has already come, right? That means, see, the EMF is now here, it is at the peak, right? So when it is starting this point, by that time itself the current has already reached its peak value, right? That is the 90-degree shift meaning, right? That is before it, the EMF has reached or started its traveling, by that time itself the current has, see, the current has already started, so it would be like this, right? Clear? Even if it doesn't look okay, I'll draw it again for proper understanding. Let's make it good. Okay, the current has already started means let's make the points first, right? So this is the current, clear? Right, the current has already started, right? by the time the EMF is starting, the current has already reached its peak value. That is the 90-degree shift. Clear? So this is the 90-degree shift here. Right? That means here the current, this is I naught, right? I believe you know this is I naught. Right, the current has already started by a 90-degree. So this current is leading the voltage. Right, what is the average current and voltage? Average voltage, you know, it's 0. Right, because it's a cycle, a sinusoidal waveform. Clear? Now next point which we have to deal with is power. Right, so just like the case of inductor, power generation of capacitor, or I can say average power is 0 itself. Right, how that is taught, that I will tell you now. So just like the previous, in the case of inductor, power is equal to VI. Right, so Vm, or I can say in place of V I have to write epsilon. Right, so epsilon I, that is epsilon naught I naught. Right, then will be sine omega t, and there is sine omega t plus pi by 2. Right, clear? Right, this sine omega t plus pi by 2, I can write it as cos omega t. So epsilon naught I naught sine omega t cos omega t. Just like the previous case, I can write it as naught by 2 sine 2 omega t. Right, that is our instantaneous power. Right, now what is average power? Average power will be integral 1 by t, integral 0 to t epsilon naught I naught by 2 sine 2 omega t, right, dt. Right, so this term is constant. I brought it outside. Epsilon naught I naught by 2t integral 0 to 2t sine 2 omega t dt. Now this entire term is 0. Right, the sinusoidal function. Right, this term is 0, means the average power P is equal to 0. Just like in the case of inductor. So both inductor and capacitor has the average power value 0. Right, so only resistor has an average power value. The other two components doesn't have. Clear? Keep that in mind, guys. Clear? Now the last section which you have to deal with is phasor diagram, just like in the case of inductor. Right, now you guys can draw it by yourself. Right, so first we will draw an axis. Right, so like this. And first, for every diagram, first draw the voltage. Draw it from the origin. Okay, this is for voltage, or I can say for EMF, like this. So it is at an angle, let's say omega t1. The current is already at a 90-degree, means this is lagging condition. This is a lagging area. This is a leading area. So this is lagging area, means this will be leading. So this will be our current. Right, and this angle will be 90 degree. Clear? I hope this much is clear. Right, and draw I smaller. Okay, clear? This is the phasor diagram for the case of a capacitor circuit. Clear? This is not tough. If you don't make the complicated stuffs. Right, so what and all things we have learned, we have combinedly talk about it. In the case of resistor, right, in the case of resistor, you have what, EMF and current of same phase. Right, whereas in the case of inductor, L, EMF and current are such a way that the current is lagging, or I can say EMF is leading. Right, whereas in the case of capacitor, EMF and current are such a way that the current is leading. Right, in the case of power, resistor has an average power as well as instantaneous power, whereas inductor and capacitor has instantaneous power but no average power. The average power is equal to 0. Keep that in mind. Clear? Now this and all things which I have taken is taken in a very slow pace, guys, so that you guys can understand it. Okay, clear?